So now let's start with our chapter 1, that is revising basic Java concepts. Firstly, introduction to Java. Java is an OOP language. Now what is OOP? OOP is object oriented programming. OOP is nothing but object oriented programming. Now what is object oriented programming? Object oriented programming or Java views a program in terms of objects and classes. Now Java views a program in terms of objects and classes. Now what are objects and classes, you may ask? Object is an identity with a specific object is an entity with a specific identity and having specific behavior. For example, if you are an object, you have some specific identity, that is your name. You have some specific behavior like how you walk, how you talk. Now I am also an object. I also have some identity. I also have some behavior. Now there are certain behavior that are similar, like we both walk on two legs. Okay. Now what are classes? A class is a blueprint representing a set of objects that share common behavior. Okay. So a class is a blueprint representing a set of objects that share common behavior. Now what you understand from this line is there are certain objects sharing same behavior. For example, here these two objects have same behavior, they both walk on two legs. So class is a blueprint representing that behavior, that set of objects, these two objects. Okay. Then comes general OOP concepts. Data abstraction. What is data abstraction? Abstraction is basically hiding of complex processes and showing only the essential features. The best example you may get is your switchboard. The switchboard hides complex processes, that are the wires, and shows only the essential features, that are the switches to you. Then comes encapsulation. Encapsulation is wrapping up of data as a single unit. Encapsulating, making something into a capsule. So wrapping up of data is a single unit. For example, like we discussed, if you are an object, so there are a lot of things inside you. Okay, there are many organs, there are many chemicals inside you, that all are wrapped up as a human body. That is encapsulation. Now comes modularity. Modularity is a property by which a Java program is broken down into different parts. What it does is it helps you, it eases a programmer to study a program and to make changes to a program and write a program, and also to understand a program. For example, if this is the project, if this is the program, we'll break it into 3 different parts. So it will easier to read one by one the 3 instead of reading the whole thing. Then comes inheritance. Inheritance is inheriting of data. For example, if, earlier there used to be a king. He had his kingdom, and there was a prince. After his death, the property or the kingdom was inherited to the prince. In the same way, we can make a class inherit some data and inherit data from another class. Polymorphism. Polymorphism is using of a single thing in multiple ways. For example, the plus operator. Okay. So what the plus operator does is, the plus operator can be used in both ways. It can be used to do 5 plus 7 equal to 12. It can be used to do A, B, C plus def equal to a b c d e f. Now what we are doing here is we are using plus in both ways, to add arithmetically and to concatenate string. So here we are studying polymorphism. Then comes introduction again. Java is both a programming language and a platform. Now what is a platform? A platform is a combination of hardware and software. For example, Windows. Windows is a platform. Platform is nothing but combination of hardware and software. Hardware like your monitor, like your keyboard, like your mouse. Software is different types of softwares. Okay. Then comes bytecode. What is bytecode in simple language? Bytecode is a code that helps Java to maintain its property of platform independence. How does it do so? So in normal process, what a programming language would have done is, for example, you are writing a code in Windows and you are compiling it. So it would generate a native executable code. Okay, it would generate a native executable code that can be run only in Windows. But as we know, Java is platform independent, so it should not be like this. So what it does is, instead of making a native executable code, it makes bytecode. Now what bytecode does is, now you can transfer this file into many different types of platforms. For example, Android, Linux, Mac OS. Now this bytecode in the platform where you want to run it will get again interpreted by a virtual machine known as Java Virtual Machine or JVM. Okay, now JVM will interpret that bytecode into its own native executable code. So understood? So what bytecode does is, it maintains the property of Java of its it maintains the property of platform independence. What it does is, for example, if you are coding in Windows, it will produce a bytecode. The bytecode can be transferred to different platforms where a native executable code will be generated by Java Virtual Machine or JVM. Therefore, it remains platform independence. Now, the code done in Windows can be made into Android, can be used into Android with this NEC or native executable code. Okay, now an important question comes in your exams, that is, which is used in Java, compiler or interpreter? Now in Java, from what we have understood above, we can say Java uses both compiler and interpreter. Compiler to make bytecode and interpreter is used in Java Virtual Machine to interpret the bytecode. Okay. So here we answer an important question that may come in your exams. Then comes parts of Java program: comments, classes, method main, code statement. Let's go in order. These are comments. Comments are only visible to the editor or the coder. It is not visible to the user and it does not create any impact into the program. Only what it does is, it helps the programmer For example, if you are making some code and you are giving it your friend to complete it, but he is not able to understand your code, so you will provide him with these comments. For example, write a description of class hello here, author your name, version at number of a date. For example, you are selling this program to someone and you want to know and you want to mention your name, that this is written by you. So you will just give comments and write @ author and your name. So this will be only visible to the programmer, not the user, and it will not create any impact into the program. It may, most of the time comments are used just for the ease of the programmer, where he can mention that, for example, in public class hello, or for example in public static void main above, he can mention the purpose for which this is created. Then comes classes, public class hello. So here hello is a class. What a class is, we just understood. Hello is a blueprint, class is a blueprint representing set of objects having common behavior. So class is a code written under these parentheses, these curly brackets, and class is made so that we can operate and ask the device to do something, and also create objects. Method main, not only method main, there may be more methods in the same class, or there may be more classes in the same file, but there has to be a main class that has the same name as the file. For example, here the file name is hello, so there has to be a class with the name hello. That is the main executable class, that is the main class that will run, and we can use the other classes inside this class. Then now there are methods. Method work in the same way. There has to be a method main which is executed. The other methods can be used in main. So what main does is, the main is the place where we provide with the main orders which we want to give to the computer. Now comes code statement. Code statement is the things you write inside the method. So what are code statements? Code statements are the way of writing orders you want to give to the computer to do something. For example, system.out.println hello class. So it will print hello class. So you are giving some order to the computer to do something. Therefore, that are code statements. Code statements are inside method main are inside classes. Okay. Then comes literals. Literals, often referred as constants, are data items that are data values. For example, 0, A, Z, null. These are some data values. So these are literals, because literals are data items that are data values. There are many kinds of literals: integer literal, whole numbers; floating point literal, numbers with fractional point 1.2; boolean literal, only true or false; true, false; character literal, single characters. Characters may be capital A, small a, 0, star, etc. String literal, one or more literals. For example, under double quotations, 0A3, this is a string. String is nothing but a combination of literals. Now comes null literal. Null represents nothing. Null represents null reference. So null is also a literal. Then comes identifiers. Identifiers are the name given to certain parts of the program by the programmer. Identifiers are the names of methods, variables, classes, etc. Identifiers, as the name suggests, helps you to identify. Therefore, identifiers are the names given to classes, methods, variables, etc. Anything that requires a name is an identifier. Anything that helps you identify something is an identifier. Identifiers have some rules. Identifier can contain alphabets, digits, underscores, and dollar. So, for example, it can, A star underscore 0. Okay, but it cannot contain A slash. Slash it cannot contain. It will not be a valid identifier. They must not be a keyword or boolean or a null literal. An identifier cannot be null. Identifier cannot be true, false. Identifier cannot be a keyword, for example, switch, class. They must not begin with a digit. You can keep A0 but not 0A. Okay. Now, uppercase and lowercase letters are treated differently. A is different, small a, is different. Okay, these are some basic rules of identifiers. Now variables. Variable is a named memory location which holds a data value of particular data type. A variable is declared as per the following syntax: type, variable name. For example, int a. Int is a data type, a is the variable name. Here double is the data type, b is the variable name. Char is the data type, c is the variable name. Now we can also initialize while declaration. What is declaration? We are declaring there is a named memory location. What is initialization? We are initializing it with a value a equal to 0. We can do it together as well, int a equal to 0. So initialization done with while declaration. Constants. Now variables can change the value a plus for example if a equals to 5, a plus plus, so a will become 6. Okay, now a will be equal to 6, but here comes the difference. Constants variable cannot change, for a constant's value cannot change. Sorry, for example, while writing a equal to 5, we write final a equal to 5, so this will be invalid because a is a constant, a cannot change its value, a will always remain 5. Now data types. Data type is identify the type of data and associated operation of handling it. Java provides many data types to support many types of data. Data types in Java belong to two categories: primitive data type, reference data types. So what is data type? A data type is used to identify the type of data that we are using. So it becomes easier for the Java language to understand what functions the thing or the data can do. There are two types of there are two categories. Data types belong to two categories: primitive data types. There are 8 primitive data types. The reference data types, there are many. 8 primitive data types are char, byte, int, short, long, boolean, float and double. These are the 8 basic or primitive data types. For example, there are primary colors. Primary colors are the colors that are at the base level, and there are secondary colors. So this is the same thing. Primitive data types are primary colors, they are at the base. Now other data types, reference data types, are made from these primary colors. The secondary colors are made from these primary colors. So there are 8 primitive data types. Char is used to store a character, byte is used to store whole numbers, int is used to store whole numbers, short is used to store whole numbers, long is used to store whole numbers, but they have different range of data that it can store. Boolean stores true value or false value. Float stores the numbers with decimals. Double stores numbers with decimals. Operators and its types. Now what are operators? Operators represent operations. For example, 5 plus 7 equal to 5 plus 7. This is operation, addition. Here operator is plus because plus is representing the operation. There are two values, 5 and 7. There may be minus, there may be divide, there may be into. So how will we know it? By operator, because operator represents the operation. There are different types of operators in Java: arithmetic operators, increment decrement operators, relational operators, logical operators, assignment operators and shorthand operators. You can read what they do from here. Now precedence of order operators. If you use too many operators together, Java has to prioritize what it does. Like you have your priorities, what is important to you. The same way there are precedence of operators. There is a list of operators in what way they are important to Java. For example, brackets are most important to Java. Then comes increment, decrement, then comes new, then comes arithmetic operators, then comes shift operators, then comes relational operators, then comes and logical operators, and or, then comes these conditional operator, then comes shorthand operator. Input in Java. You have to take some inputs in Java to operate. For example, if you have to add something, if you are creating a program to add two numbers, you take two numbers from the user. So you are taking two inputs from the user. How to take that input? Firstly, we have to import a package. We use import keyword. Import keyword is used. Then there is import java.util.star. Why java.util.star? Because java.util.star is the package we require to take inputs in Java. Okay, then we have to create object of scanner class. So when we import this package, there is a scanner class imported into our code. So we'll create an object scanner sc equal to new scanner system.in. So here we are creating an object of the scanner class. Now to use the functions of scanner class, for example, sc.nextInt is a function. NextInt is a function of scanner class which is used to import, which is used to take input in the int data type. So we use the object, for example, int a equal to sc.nextInt. This is the object, this is the function. Then comes expression. An expression in Java is a valid combination of operators, constants, variables that are legal combination of tokens. Expressions can be of different types: arithmetic, relational, compound. For example, 100 plus 1 equal to 0, 1. This is an expression. This is a arithmetic expression. Conditional construct in Java. In some programs, we require a conditional construct. If this is happening, then do this, else do this. If this is happening, do this, or if this is happening, do this, or this is happening, do this, else do this. So here if else is used. If expression is happening, so execute statement 1. If it is not, else statement 2. There is also else if expression 2 is happening, statement 3 has to be executed. So first it will check if expression is happening. No problem. It will go to else if expression 2 is happening. Yes, statement 3 will be executed. If there is if there is no mandatory that we put a else, but if you are putting else if, it is mandatory to put else. Then comes switch statements. In some cases there are many options available. Okay, there are many options. For example, enter a number or a menu based program. Okay, so there is enter 1 for this, 2 for this, 3 for this, 4 for this, 5 for this. You will not write else if again and again. Instead you can use switch statement. What switch does is, this is the syntax, we write switch, then the expression. Okay, this is the variable where we store the value. For example, you are inputting the value that the user gives in a, so a will be stored here. Then we'll check case 1. If a is 1, so statement 1 will be done. If case 2, there is some constant. If a is equal to this constant, statement will execute. If a is equal to this constant, statement 2 will execute. Like this way you can put unlimited number of cases. Now comes iterative constructs. There are some things that you want to do again and again in a program. Okay, so that are called iterative constructs. There are different types of constructs: loop or loops, for loop, while loop, do while loop. In for loop, this is the syntax. While loop, this is the syntax. Do while loop, this is the syntax. In for, initialization, condition, update expression has to be mentioned like this and is written together. While condition has to be mentioned, initialization can be done before or inside the that has to be done before the loop, and update expression has to be done inside the loop. In do while, the condition is at last, so it is not mandatory that these two will run at least one time, but do while will run at least once, okay, because condition is at last. So this was our chapter 1. I hope you understood chapter 1 and you're clear with it. This was basically revision of some basic concepts that we have learned in earlier classes, class 8 and 9. So this must have been easy, but the next chapters will not be. We have to study properly to score at least 90% in computer, and we have to aim 100% in a computer, because computer is a scoring subject and we can score easily in it. Okay, so this was the end of chapter 1. Notes are available for download. This PowerPoint will be available for download with all the handwritings that I have put, and also revise these notes earlier. You can watch this video, that will be the best thing, but you can also read these notes. These will help a lot. Try to solve some questions as well.